So what if you could make a move in the world of crypto and nobody could see it coming? Today, we're going to pull back the curtain on the cryptographic magic that's letting users shield their transactions from prying eyes, creating a powerful defense against the predators lurking on the blockchain.
All right, let's just dive right in. The thing about public blockchains is, well, they're public. Every transaction is out in the open. It's kind of like you're operating in this financial dark forest, and there are these sophisticated predators, these bots that are watching your every single move, just waiting to extract value from you.
And this whole problem, it actually has a name: maximal extractable value, or MEV for short. You can just think of it as this invisible tax that pretty much all users are paying to these bots, and it's costing the ecosystem a fortune, all because the blockchain is so transparent. So here's how a classic front-running attack plays out. You decide to make a trade and you send that transaction out. Now, before it gets confirmed, it sits in this public waiting room called the mempool. A bot sees your trade there, and in a flash, it copies your trade but pays a higher fee to cut in front of you in line. Its trade goes through first, pushing the price up. And then the bot turns around and sells that asset right back to you at the now inflated price. It's a risk-free profit for the bot, and it comes directly out of your pocket. So you have to ask the question, right? How can you possibly operate in an environment like this without basically broadcasting your entire strategy to every bot that's watching? How do you prove you have the funds, that you're following the rules, without showing everyone the details of what you're doing? Well, the answer comes from this amazing field of cryptography that honestly sounds like something straight out of science fiction: zero-knowledge proofs, or ZKPs. And this isn't just theory. This tech is actually building the foundation for a much more private and secure Web3.
You know, the core idea is really right there in the name. A ZKP lets you, the approver, convince someone else, the verifier, that you know something, like a password, or that you have enough money for a trade, without ever revealing the secret information itself. The verifier learns absolutely nothing, except for the fact that your statement is true.
Now, I know this sounds impossibly complex, doesn't it? But what's so cool is that we can get the main idea with a super simple story that's been around since the 80s. It's called the cave analogy. And trust me, it makes this whole concept just click. Okay, picture this. There's a circular cave. It has two paths, path A and path B, and they're connected at the very back by a locked door. Now, our hero, Peggy, she's the prover, claims she knows the secret password to this door. She goes into the cave all by herself, while Victor, our verifier, waits outside where he can't see which path she takes.
A moment later, Victor randomly shouts which path he wants her to come out of. Let's say he yells, "Come out of path B." Well, if Petty went down path A, it's no problem. She just uses her secret password, opens that door at the back, and walks out of path B. And if she was already in path B to begin with, well, she just walks right out. Either way, she can always do what he asks.
Now look, the first time could just be luck, right? A 50-50 shot. But what if they do it again and again and again, dozens of times, and every single time Peggy comes out of the path Victor calls? The odds of her just getting lucky become astronomically small. Victor becomes totally convinced she must know the password, but here's the magic part: she never ever had to tell it to him. And that right there is the essence of a zero-knowledge proof.
Okay, so this next part is really important because you've probably heard about ZK tech in a totally different context. It's a huge point of confusion for a lot of people, but you gotta understand that not all ZK is created equal. So here's the key takeaway. ZK rollups, the kind used by scaling solutions like CK Sync or Polygon, are all about efficiency. They take thousands of public transactions, bundle them up, and create one single proof that says, hey, all these are valid. It saves a ton of space, it makes things cheaper, but it does absolutely nothing for privacy. The details of those transactions are still completely transparent. And this table just lays it out perfectly. On the left, you've got ZK for scaling. The goal is efficiency. It proves a batch of public transactions is valid. But on the right, you have ZK for privacy. The goal there is confidentiality. It proves a single transaction is valid while keeping all the important details: who sent it, who received it, and how much, completely encrypted. The goal is totally different. So let's see how this privacy-focused version of ZK is being used to build that powerful defense for DeFi users we were talking about. We're talking about creating the crypto equivalent of dark pools, but right on chain. See, instead of operating in that transparent glass box of public DeFi, where bots can see and front-run your every move,
Private DeFi protocols create what's called a shielded pool. Inside this pool, your assets and all your activities are encrypted. You can still prove that you're following the rules of, say, a decentralized exchange, but you never have to reveal your specific strategy or how much you're trading.
And the benefits for you, the user, are huge and immediate. Suddenly, you're invisible to those front-running bots. Your trading history, your wallet balance, it's all kept secret. You can do things like confidential token swaps or take out a loan without the whole world knowing about it. You're basically cloaking yourself from all that predatory behavior.
And this is not just some idea for the future. You've got projects like Aztec and Railgun that are actively building these systems right now on top of public blockchains like Ethereum. They use ZKPs to let you deposit your funds into a shared private pool where you can transact completely confidentially and then withdraw back to a public address when you're done.
Okay, so let's zoom out for a second, because the implications of this technology go way, way beyond just protecting DeFi traders. This is really about rebuilding how we think about digital trust from the ground up.
I mean, just think about it. For a major bank or a hedge fund to bring billions of dollars on-chain, they simply cannot just broadcast their trading activity and all their client positions for their competitors and the entire world to see. It's an absolute non-starter.
And this is where you get really clever solutions like ZK Sync's Prividian. It gives these big institutions the best of both worlds. They get a private, permission chain where all their sensitive data stays totally confidential. But every single transaction is still anchored to the incredible security of the public Ethereum mainnet using a zero-knowledge proof. They can even choose to selectively reveal certain data to auditors without having to open up their entire books.
And the potential uses for this are just exploding. We're seeing it expand into all these other areas of our digital lives, moving far beyond just finance to solve some really fundamental problems about trust and verification online.
I mean, we're seeing ZKPs being looked at for everything from secure, tamper-proof online voting to digital identity systems where you could say, prove you're over 18 without ever showing your actual driver's license or birth date. Imagine being able to verify an AI model's decision process without having to reveal its secret sauce. That is the kind of power we're talking about.
So the really big takeaway here is that ZK technology isn't just some academic curiosity anymore, and it's not just for niche privacy coins. It is quickly becoming a fundamental building block for a web where privacy, security, and the ability to prove things are true can all exist together right from the start.
And that really leaves us with a powerful thought to chew on. What does our digital world look like when we no longer have to make that choice between participating in something and protecting our privacy? What happens when confidentiality isn't just an extra feature you have to opt into, but it's the very foundation the entire system is built on? That's the future ZKPs are starting to make possible.